Hello and welcome to MOS Live. My name is Maida. My pronouns are she and her. And today we're going to be, and you are just in time, for Coolest Science Stories, where today we're going to be talking about a update on the tiniest dinosaur, as well as some updates on those long forgotten murder hornets. Now, if you have questions throughout our presentation and you are joining us on Zoom, you can put those questions into that Q&A tab at any point throughout our presentation. But if you are joining us on Facebook, we are so glad to have you join us. Unfortunately, we cannot see any of your comments. Now, if you do want to see some closed captioning, there is a closed captioning available in that closed captioning tab at the bottom of your screen. Now, at this point, I would like to ask my fellow educator to introduce herself.
Hi, my name is Meg. My pronouns are she and her. And today, in addition to murder hornets and tiny dinosaurs, I'll be talking about a kind of artificial intelligence that needs to sleep, just like us.
Awesome. Well, I'm going to go ahead and get us started talking about tiny dinosaurs. Now, a couple of months ago, I did a presentation on the recently discovered smallest dinosaur. And we talked a little bit about how when we think of dinosaurs, we usually think of the big ones like T-Rex, Stegosaurus, and Triceratops. We don't usually think of the tiny ones, and that could be for a lot of reasons. But one of them is because tiny bones tend to get crushed under sediment and just don't last very long. However, we do know that birds are related to dinosaurs. In fact, they're often referred to as modern day dinosaurs. And the smallest known bird is the bee hummingbird, which means that about 2-ish inches tall, it's also the smallest known dinosaur. That was until we found a brand new skull. Now, this skull was preserved in Burmese amber and is old enough to be a dinosaur. It's believed to be about 99 million years old because, as anyone who's seen Jurassic Park knows, that Burmese amber can protect really old things for a really long time. Now, so in order to protect this specimen, scientists did a type of X-ray imaging to get this 3D model. And they named this new species Oculidentavis congre, which means eye-tooth bird. And at the time, that name made sense because this new species has very unique eye characteristics and teeth characteristics and was eventually considered to be a type of bird. Now, if you watch that original presentation, you might remember that this species had some bird-like characteristics, it had some dinosaur-like characteristics, and even some random lizard-like characteristics. But eventually, scientists did conclude that it was somewhere between traditional dinosaurs like T-Rex and modern birds like our bee hummingbird. However, there's been a new study that just came out, and ironically, they discovered that it was exactly those eyes and teeth that this dinosaur is named after that make this eye-tooth bird, well, not a bird at all. Instead, they're pretty sure it's a type of lizard. So let's talk about why. Well, this is originally what scientists believe this new species might look like. And you can see it's absolutely adorable. But let's talk about those unique teeth and eyes, starting with the eyes, because the shape of the bones surrounding the eyes actually do match those of lizards. And the original authors did mention that. However, there are some dinosaurs that have similar characteristics, so they just thought that the eyes could be dinosaur eyes. So let's talk about those teeth, because those are a little bit harder to explain. After all, we know that modern birds don't have any teeth. However, we do know that early birds like Archaeopteryx did have teeth. Nowhere near as much as this guy though, and not fused to the jaw. Because just like us, dinosaurs and early birds have little pockets where their teeth go in. But lizards have their teeth fused to their jaw, and so does this new animal. Now, I really want to talk about these updates because I think it's just fascinating that with new science, we get a new understanding of how the world works. After all, originally, all of the evidence or most of the evidence pointed to bird. And even computer algorithms that were given all of the data and all of the characteristics concluded every single time that this new species had more bird-like characteristics than anything else. And yet, this new study has convinced even the original authors enough that they retracted their original paper. Now, we still don't know exactly where oculodentavis falls, but that just means we need some more data. And thankfully, there has been a discovery of a brand new specimen of this exact same species. And while that paper hasn't been published yet, once it is, we'll have even more evidence to be able to make an even better conclusion. And well, with that, I think it is time to hop on over to Meg, who's going to tell us a little bit about a robot.
Thanks, Myra. Thanks for that adorable story. I'm just going to share my screen here. And just as a reminder, if you have any questions and you're on Zoom, you can type them into the Q&A box at the bottom of the screen, and we'll answer as many as we can at the end. So now, have you ever stayed up too long? And how did that make you feel? What about after you got some sleep? Do you think your computer would feel that good if it got some sleep too? Well, a new study from the Los Alamos National Lab shows that some kinds of artificial intelligence, or AI, might benefit from sleep, just like we do. To understand how that could be possible, let's take a look at how sleep works for us. Your brain is an electrochemical organ, which means that the brain cells or neurons that make up your brain transmit signals to each other via tiny electric impulses or brain waves. These brain waves fire faster or slower depending on what you're doing. They're pretty fast or high frequency when you're awake and engaged in something like watching a really cool science video. And when you start to fall asleep, your brainwaves start to slow down, and they go through several stages until you reach deep sleep or slow wave sleep. Over the course of a night, you actually cycle through all these different sleep stages, going from slow wave sleep back up to lighter sleep, where you might experience dreaming, and all the way back down. Scientists are still working to understand exactly what slow wave sleep does for us, but it seems to be involved in refreshing and repairing brain cells and other systems of the body that have been working hard all day. That's why you feel so much better after having a good night's rest. Now, a team of researchers thinks that similar benefits of sleep might help keep artificial intelligence programs running smoothly too. They're using a special kind of program called a spiking neural network to try and approximate how humans perceive and recognize images. Neural networks in general are computer algorithms that are really good at recognizing patterns, like interpreting this handwritten number 7 correctly. And they're built to mimic how our brains do that task. A spiking neural network is a special type that goes one step further, and it mimics how the brain's neurons fire in bursts rather than all the time. This is really hard to do, but the payoff is huge in terms of power efficiency. Just think of all the amazing things your brain can do, and it only runs on about 20 watts of power. That's less power than it takes to power a laptop computer. The research team gave their program a particular task called unsupervised dictionary learning, which is a fancy way of saying they gave it some images to look at, and then they asked it to come up with a dictionary of visual elements, the words, to describe them. By using this kind of training for their neural network, they were hoping to recreate how humans learn from their environment during childhood just by taking in their surroundings. So it's a little like handing you a cookie and asking you to figure out the recipe just by eating it. You could probably come up with some good ideas all on your own, that is unsupervised. And that's what this team of researchers did with their spiking neural network, but with images instead of cookies. They gave their AI many images, and these are all from a well-known data set of tiny pictures, just 32 pixels on a side. So you can sort of see a pixelated car, a frog if you squint, and a blurry truck. It actually doesn't matter what's in the picture or how crisp the image is, because they're interested here in whether the program can learn how to reproduce the images. So left to its own devices, they set this program to learn a dictionary of visual words, and it came up with something like this. This might look a little strange, but the important thing to notice is how different these little squares all are from each other. They have different patterns and colors, so that between all of them, they make up a whole vocabulary to describe lots of different images. Then, from combinations of these strange looking words, the team asked their AI to recreate the original images. Imagine if we asked you to bake the same cookies just based on what you learned from eating one. You might get pretty close, and so did they. It seems like the program really did learn what some of the most important visual elements are to describe the images they started with, to a pretty good extent. But they ran into an unexpected problem along the way. During these unsupervised learning periods, the spiking neural network started to become unstable, meaning that the nodes in the network would get carried away and they would start spiking in response to just noise. And then soon they were firing all the time and they were completely messing up the simulation. Here's what their dictionary started to look like over time. So at first it's going through the images bit by bit, and some reasonable looking visual words start to show up with different patterns. But then as it keeps learning, the nodes just start spiking all the time and the words start to all look the same. They become meaningless. The researchers struggled to figure out what was going wrong until they tried something a little unusual. They broke up the unsupervised learning periods and spaced them out with naps. In between short bursts of learning from the actual images, they started showing the AI fake images that were just noise, and they changed the noise over time in this wave-like pattern. When they set the AI to learn its dictionary this time, it behaved very differently. Instead of the spikes growing continuously over time, they calmed down. And after some learning, they started to see some reasonable visual words showing up in their learned dictionary. And after even more learning, instead of becoming all the same and meaningless, they became more distinct and unique, which became more useful to them. It's what they wanted. So these little naps calmed down the spiking neurons and kept them from hallucinating. This sleep-inspired technique is likely to be useful for all sorts of future applications, and they want to use it next on a neuromorphic chip, which is a hardware piece specifically designed for these types of programs. They also wonder what this research might tell us about our own brains, and they speculate that maybe one reason why slow wave sleep may have evolved is to keep our own neurons on task. And with that, I'm going to turn it back over to Myra, and we have one more story for you today.
Thank you, Meg. The idea that computers need sleep as much as we do is absolutely fascinating. I love that. But on to our last story. We're actually going to have a few updates on those murder hornets, because as you might remember, a few months ago, you couldn't scroll through social media without seeing all of these posts on the murder hornets pop up. But then all of a sudden, it seemed like they completely disappeared. And while they did disappear from our newsfeed, the murder hornets or the wasp themselves did not disappear at all. In fact, there actually been updates and they've been reproducing. So let's talk about that. In fact, let's go ahead and give a little bit of a refresher on what these hornets even are. Now, murder hornets are the largest species of wasp in the world. They are about 2.5 inches long. They have a yellowish orangish face, prominent eyes, and a yellow and black striped abdomen. Now, while they were given the nickname murder hornets here in the United States, their original common name is Asian giant hornet, and their scientific name is Vespa mandarina. And the reason that they were in the news is because this was the very first time that we had seen this species here in the United States. Now, you might be wondering, why does that matter? Or even, does that stinger really hurt? So let's talk about both of those. First off, YouTuber Coyote Peterson did a video where he did get stung by the Asian giant hornet. And as you can see in the video, his arm starts to swell almost immediately. And he says that the pain was pretty excruciating. But despite all of that, these hornets really are not as big of a threat to humans as their nickname would suggest. Instead, their biggest threat is to bees. Now, this is a picture of what these hornets can do within just a few hours. They can completely decimate a previously healthy colony of bees. And because so much of our food, agriculture, and economy is dependent on bees, this is definitely a problem. And now, again, you might be wondering, why are we even talking about this? This in 2020, this seems to have been a side plot that was easily abandoned. But in actuality, this is a problem and it's only getting worse. Let's talk about why. And that's because in this last year, we have had several new sightings of this species. In fact, we've caught 3 new species so far, and that means a few things. It suggests that the individuals that we found in December were actually part of a nest that was able to produce queens. Now, nests usually produce about 200 to 300 queens every winter. Those queens then go into hibernation underground and come out in the spring. So the ones that we've found this year are new queens that have come out, which means that there are potentially still 200 to 300 more that we need to find. And the newest specimen that we found is even more interesting. Now, this new specimen is somewhere in the size, somewhere between a typical worker and a typical queen, which means that we still don't actually know if it's a worker or a queen. Now, previously, we've only found queens, which is a good thing. But if this is considered to be a worker, it means that there is now officially an established nest that needs to be eradicated before winter, when it once again makes another 200 to 300 queens. And you can see where that cycle would start to become a big, big problem. And so that's the bad news. However, we do have some good news. This specimen is the very first specimen that was actually collected from a trap set by the Washington State Department of Agriculture. And that just means that these traps work, which is a good thing. Now, we are still early in the year, which means that even if nests do get established, we're not going to see workers for a while. But now that we know that these traps work, it means that we can now trap those workers, and then we can put little tiny cameras or radios on those workers and follow them right back to their nests. The reason why that's important is because this species actually has nests underground. And as you can imagine, us humans who live above ground, it's very hard for us to find something that's underground. Now, currently, WSDA, which is the Washington State Department of Agriculture, is in charge of finding and eradicating the species, but they do ask the help of everybody. So if you do happen to live in the Washington area, please keep an eye out for these guys. Make sure if you do see them or any sign of them to take pictures and report it to WSDA. Currently, they do believe that we can still eradicate the species completely from the United States. That is our goal, but we're not going to be able to know much more until the season keeps going around September or October. And well, on that happy and fun news, let's go ahead and I'm going to ask Meg to join us again. We're going to answer some of y'all's fun questions. So Meg, I want to know, why do we humans, as well as other things, have to sleep? It's just, again, so strange that.
Yeah,
So
that's a
just
good question. And sleep research is a very active field of research. So there are scientists out there right now still trying to understand a lot of the benefits of sleep or what is really going on. But we do have some ideas, and it seems that during that slow wave period of sleep for humans, several things are going on. One is that the brain itself seems to consume more glucose during those slow wave sleep periods. So we think that the brain cells themselves are being refreshed during that time. And it's also the time when human growth hormone is secreted. So being sent to all the other parts of the body that need to be repaired or need to grow while we're sleeping. So it's really an important period of time for our bodies to sort of, I mean, it's a little cliche to say they need to rest up, but that's exactly what's happening. They're getting their R&R, and during that time, all of our systems that have been working hard all day are getting a little refresh. So that's why we think, at least some of the reasons why we sleep. The researchers in this study are also speculating that these kinds of noise patterns that they're feeding their programs might have an analog to our own neurons sort of firing, becoming more regulated in their firing so that they don't go off the deep end and start hallucinating. So that's their thought. Someone on the brain science side would need to pick up that idea and look at it further. But it is a really interesting idea that maybe we can learn something about brains by studying computers and vice versa.
that's so
So
interesting.
I have a question. Actually, Clement, age 9, on here has a bunch of questions for Myra. I'm going to group two of these questions together about hornets. Um, what is the deadliest hornet, and how many species of hornet are there?
Awesome questions. So those are great questions that I don't actually know the answers to. Um, in terms of the deadliest, I know that there are many species that have very potent venom. So for sure, this one could be deadly if you got stung multiple times. I don't know that there's any species that would be deadly to humans if it only stung us one time and you were not allergic to it. But there are many that definitely hurt and are pretty deadly, specifically to whatever it is that they would want to sting, usually their prey or other animals that want to get into the nests. So Meg, Karen wants to know, why does my dog sleep so much? Is he just lazy?
uh, that's a good question too. Dogs can really sleep a lot, it seems. And I think there's two parts to this question. One is sort of getting back to the earlier question, why do we sleep at all? And it is a really good refresh period for dogs as well as humans. But then dogs in particular, and Myra can correct me if I'm wrong because I think you know a little more about dogs than I do. But there's dogs actually are capable of sleeping a lot and storing up all of their energy for that one moment when they really need it, and then they can spring into action, and then they have a huge reserve of energy for those special times when they especially need it. So I would say your dog isn't necessarily being lazy. He's actually being really economical with his energy, and he's waiting for the right moment when he's going to need it all at once.
Yeah.
uh, is that about right?
Yeah, and then I guess just adding that dogs are crepuscular, which is a fun term that basically just means that dogs do best around dawn and around sunset, meaning that during the day, they are meant to sleep during the day and during the night.
Well, I have another question from Myra, from Clement. Here we go. Are there birds living during the dinosaur times?
Yeah, that's awesome question. And yes, the answer is definitely yes. We know that at the end of the Cretaceous, we had some birds that we officially consider birds. The problem is that it's very difficult to know exactly where dinosaurs end and birds start, right? Their descendant birds are descended from dinosaurs, so drawing a clear line is difficult, but we know that we did have some early birds like Archaeopteryx during the Cretaceous in the time of the dinosaurs. Cool. So Meg, Sharon wants to know, how long did it take for scientists to make the robot?
Yeah, that's a good question too. They've been working on it for quite a while, and I should say so. The way that these types of research projects work is that they tend to, whatever topic they're working on, they can make lots of innovations over time. So the data from this presentation actually came from 2 different papers over the past few years, where first they were proving that their robot could actually learn a dictionary from those images at all. And then just recently, they published this other paper about the sleep issue, and then they're describing sort of the struggle that they went through trying to understand why they were having problems to begin with. So these things really can take a while to really unpack what's going on and to understand it well enough to publish a paper about it. So they've been working on this for the past several years, and they'll continue working on it because they have this next exciting step to try it out on this Intel chip, which is a specially designed hardware where where all of the little connections in the physical board are set up in a way to make a program like this work especially well. So I'm excited to see more work into the future, but several years, yes.
Not a just overnight type of thing.
No, no, and it takes a bunch of people and a bunch of time for sure to tease out all of these little nuanced details of things. So
well, that makes sense.
We still have a couple minutes. I'm trying to see if I missed any questions. Okay, one more from Faith, who's age 9. Are the murder hornets deadly to us? I'll add.
Yes, the answer. So first off, if you're allergic to that venom, then they are definitely deadly. However, multiple stings of this species could also be deadly. So there are about like 50-ish people that die every year from this exact species. However, it usually takes multiple stings. So as long as you leave a nest alone, and that is why WSDA says that if you find this species, take a picture, but do not go near them, because once again, multiple stings could be deadly to humans. And well, I think that's all the time we have for all of these questions. Thank you guys so much for asking. I'm sorry we didn't get through all of them. But at this point, I would like to ask Meg to say her final goodbyes to our audience.
Thanks, everybody. Thanks for watching, and we'll see you next time.
Awesome. And cool. And yeah, so thank you guys so much for joining us. And if you liked this, please go ahead and join us again at MOS at Home to see all of our fun videos. And if you like this and would like to support us, please go ahead and visit engage.mos.org/welcome. Thank you guys so much and have a wonderful rest of your day.